Hello everyone, welcome to Scholar Lab. Our simulations can transform your teaching approach, making lessons much more interactive and captivating for your students. Scholar Lab is a distinctive virtual laboratory that brings intricate STEM concepts to life through engaging simulations. This tool is crafted to aid students in comprehending and applying scientific principles in practical situations. Today, we are diving into a simulation that will bring the world of chemistry to life, making abstract concepts tangible and easy to understand. We'll explore mole mass conversions, calculate volume under STP and RTP conditions, and compare the masses of equal moles of different particles. This simulation is designed to help you grasp these key stoichiometric principles in a fun and interactive way. Let me open stoichiometry simulation for you. Each simulation begins with a game plan. This outlines the overall objective of the simulation. Our main objective of this simulation is to provide a visual representation of the mole concept and stoichiometry to demonstrate how the concept is applied in chemistry as well as in real life. This simulation consists of four important parts: mole by mass, mole by volume, mole by balance, and finally quiz. Let's start with the concept of mole mass conversions. This is one of the most fundamental ideas in stoichiometry. The mole is a bridge between the atomic world and the microscopic world. It connects the number of particles through their mass. In this part of simulation, you will be able to input the number of moles of any given substance and see its mass instantly calculated. Let's start with salt, that is NaCl. The atomic mass of sodium is 23 and the atomic mass of chloride, that is 35.5. Let me place the beaker on the balance by clicking on it. You can see the information on the board, which is mentioning that with the help of the setup, provide the amount of grams for dash moles of salt. Now we are going to enter the number of moles on the tab. Let's say I want to measure 1 mole of NaCl. To convert mole to grams, we have to use the formula. You can click on this bottom F button to reveal the formula. Amount of grams, which is equal to number of moles into molecular mass. We know that molecular mass of NaCl, that is 58.5. So 1 mole, that is equal to 58.5 grams. Let me click on submit to check whether the answer is right or not. That is right. That is indicated by the green color, and automatically it adds to that much amount of NaCl to the beaker. You can do one more or any other gaseous and liquid substances from the list. Let's take a gaseous substance, that is ammonia. Here we have atomic mass of nitrogen is 14 and atomic mass of hydrogen, that is 1. Two mole of ammonia, which is equal to how many grams? You can pose this question to the students to understand how much they have understood the concept. The total molecular mass of ammonia is 17. So 2 moles, that will become 34. You can try converting different moles of common compounds. Notice how easy it becomes to visualize the mass of the substance once you know its molar mass or molecular mass. This will give students a strong foundation for understanding the reactions and chemical equations. Now, let's move on to calculating the volume under standard temperature pressure and room temperature pressure. This is another critical component in stoichiometry that will be demonstrated in this simulation. At STP, that is 0 degrees Celsius and 1 atm pressure, and RTP, that is 25 degrees Celsius and 1 atm pressure. 1 mole of any gas occupies 22.4 liters in STP condition, and in RTP condition it occupies 24.4 liters. First of all, you have to select the proper condition. Let me select RTP condition. Here we have three different gases. Those are carbon dioxide, sulfur dioxide and ammonia. Let me select carbon dioxide, and here we have to enter the number of moles. Let me add 2. And what would be the volume occupied by 2 moles of carbon dioxide? For that, you can use this formula button to reveal the formula that is mentioned over here. The number of moles into 24.4 liter for RTP condition. So 2 moles into 24.4, which is equal to 48.8. As you can see, it automatically fill up the gas on the container. Since we have selected RTP condition, the temperature is 25 degrees Celsius and the pressure is 1 atm. Similarly, you can try it out with sulfur dioxide and ammonia. Also, you can switch between STP and RTP conditions to compare the volumes of various gases, helping students to understand how gases behave under different conditions. Let's move on to the final part, that is mole by mass. Here, we are going to compare the masses of equal moles of different particles. This part of simulation is crucial for understanding how different substances, even in the same amount of moles, can have very different masses due to their molar masses. Here we have 2 tabs to select the compound listed below. Here we have salt, that is NaCl, water and Gopal for the first part. Let me select water. As a second compound, you can select iron or sulfur or ethanol. Let me select ethanol. By clicking on generate questions, the beakers are automatically placed on the balance. Now we have to enter the moles. Let me put 2 moles. And the 2 mole of water, which is equal to how many grams? The molar mass of water, that is 18 gram per mole. So the grams of water will be 2 into 18, that will become 36. Also for ethanol, the molar mass of ethanol is that the number of carbons in ethanol is 2, so 2 into 12, plus number of hydrogen in ethanol, that is 6, that is 6 into 1, plus number of oxygen in ethanol, that is 1, so 16 per oxygen, Total 46. So 2 moles of ethanol, which is equal to into 2. Let me put 92. By clicking on submit button, it will show green glow whether that is right, that will show red glow if that is wrong. You can see on the balance ethanol that is most weighed among these two, that's why it went down. This not only reinforces the concept of molar mass but also helps students how mass varies dramatically between different elements and compounds. You can try comparing the equal moles of different gases or compounds listed below and explore how the mass of those substances differs. It is a great way to make abstract numbers feel more concrete. Finally, we have quiz in this simulation. Here we have set of 5 questions and all 5 questions must be answered before hitting on the submit button. By clicking on the submit button, it will reveal your scores and also you can click on check answers to check whether the answers are right and wrong. And don't forget to click on explanation to reveal the explanation of the answers. This simulation is not just about getting the right answer, but about understanding the relationship between these essential stoichiometric principles. It offers a hands-on approach that makes the learning chemistry both fun and insightful. Now it's your time to dive into the simulation, experiment with different compounds, adjust the moles, and see how these principles play out in real time. By end of it, stoichiometry will no longer feel like a challenge, but a tool you can use confidently in chemistry. Thanks for watching.